Hello, and welcome to my second video on crazy formulas. So as I did with the first video, let's jump right into the problem. So here we have that Kayla needs $30,000, so I'll underline that number, for a down payment on a house she plans to purchase in 8 years. I'll underline that number as well. She decides to invest in a savings account which gets 3.5% interest compounded at the end of each year. Assume she makes the same deposit on January 1st each of the 8 years and makes no other deposits or withdrawals throughout the year. Use the crazy formula. So here we have our formula for this problem. And then we're told where A is the amount of money in the account after T years, D is the number of dollars invested at the beginning of each year, and R is the annual interest rate of the account. How much money should Kayla put in the account at the beginning of each year to reach her goal? So as we do with these problems with these crazy formulas, let's identify what each part of the formula is, and then we'll put it all in and solve for what we're being asked to find. So A, again, is the amount of money in the account after T years. In the first sentence, we're told that Kayla needs $30,000 after 8 years. So since that's the case, 30,000 is our value for A. D is the number of dollars invested at the beginning of each year. Well, technically, that's what we're being asked to solve for. We're asked to determine how much Kayla needs to be put in at the beginning of each year. So I'll perhaps just put X in for D, because that's what we're solving for. R is the annual interest rate of the account. That was 3.5%. As with other problems, when we go to plug this interest rate of 3.5% into our formula, we need to convert it into a decimal. So 3.5% we know is equal to 0.035. And T again is the number of years, and this is all going to happen over 8 years. So T is equal to 8. So now that we know what these parts are to our formula, let's plug them in. So again, our formula says A, which is 30,000, should equal D over R. D is our unknown, so I'll write X over R, and R is our interest rate, which in this problem is 0.035. And then that's times a big parentheses with another parentheses of 1 plus our R value again of 0.035. That parentheses needs to be raised to the value of T, which is 8. And then we're supposed to subtract 1 from all of that. So now, unfortunately, we have to do some separate calculations here to solve for X. I would perhaps recommend calculating what this all is equal to in our parentheses. All of that inside that big parentheses you can plug into your calculator. And if you do that, just make sure that you carry out your decimals until the very end of the problem, and you should get a value of 0.316809037. Then next, to solve for X, I don't like this fraction. I do not like to divide them by 0.035. So hopefully you would agree that if we multiply both sides by 0.035, that would help just to get rid of that fraction in that denominator. Right? This multiplying of 0.035 is going to cancel out that fraction. And then the left side of our equation, if we multiply the 30,000 by 0.035, we should get a value of 1050. And that should equal our X times this 0.316809037. And then the last thing we need to do to solve for X is divide both sides by this 0.3168090 0.037. Do that on both sides. I apologize for my bad handwriting, but after dividing both sides by that long decimal, you should get an answer of $3,314.30. And that's the value that Kayla needs to deposit into the bank at the beginning of each year so that she can have $30,000 by the end of 8 years. Once again, I hope this video helped you out to understand how to answer this question, and hopefully I'll see you again in video number 3. Take care.